Unit 3 of the Magento 2 Fundamentals course contains 7 modules. The suggested flow of the course is indicated by the arrows. However, you are free to access any of the modules at any time by simply clicking the Home button on the bottom of each slide. In this module, you will be introduced to how templates, blocks, and the design layout XML schema work in Magento 2. The following slides present an overview of the rendering system in Magento 2, focusing on templates, blocks, UI components, and layout XML. Each of these 3 aspects will be taught first in isolation to make important concepts easier to understand. Then the course will address how all the pieces fit together using best practices. Templates in Magento are PHTML files that contain HTML and PHP instructions. In Magento 1, PHTML is the only option. In Magento 2, it is possible to use any rendering system, although PHTML is the one used by default. The concept of blocks is a unique aspect of Magento. Blocks allow you to move reusable functionality from PHP template files into classes so they can be repurposed for other template files in the future. There are several block types in Magento 2. A block is a class that calls a template and provides data to that template. Blocks often instantiate models, which can then query databases, and so on. While blocks are view elements that are rendered totally in the back end, a UI component is a piece of UI that is rendered by JavaScript. However, it still depends on the back end to obtain its data. We will discuss this in more detail later in the course. Layout XML is an XML file where you define the structure of a page using XML instructions. While layout itself has changed in Magento 2, the overall concepts behind layout remain the same. Throughout the course, you have seen this diagram depicting the overall routing flow within an application. In this unit, we will be focusing on the last 2 aspects, rendering and flushing output. It is important to understand these steps to be able to debug each of them properly. This graphic shows the general process flow for rendering pages within a website. As mentioned earlier, the general concepts behind rendering are very similar in Magento 1 and 2. In Magento 2, we have 2 rendering systems that are important. One of them provides the rendering layout and operates similarly to Magento 1. The second one is based on page objects. There are 2 rendering layouts, View Load Layout and View Render Layout. This module focuses on the rendering flow process. In this module, we discuss aspects of the rendering flow process, result, and page objects. This updated version of the routing flow diagram now shows you the methods that correspond to key steps in the rendering process. Here is a high-level depiction of the result object flow. It starts with the app launch, goes to front controller dispatch, then to the action. The controller then executes until result factory create is created and returns a page object. Afterwards, the application goes back to the object page, render result. This is the new rendering flow. In Magento 1, the controller loads the layout, whereas in Magento 2, the controller only creates page objects and sends them back to app launch. Note that only one step creates and renders the result page. A detailed listing of result objects in Magento 2. The code shown above provides an example of how a page object is used. The result object has 3 methods. The most important one is render result. The implementation of that interface can be found in Magento, Framework, View, Result, Page, which extends Magento, Framework, View, Result, Layout, extends Magento, Framework, Controller, Abstract Result, implements Result Interface. Reference. Locate the result object in the Magento installation. See the reference in your user guide. The most important part of this piece of code is the render result method, which the result object has to implement to effect the rendering. This diagram shows how page render result works. It takes a number of steps, starting with app and then going through the flow depicted on the slide. Note that page render page includes the root template. Including root template is a very important step because of the way templates are rendered. Root template includes all the major elements of the page, such as head attribute, body content, and so on. You can find root template in Magento, Theme, View, Base, Templates, root.phtml. We will look at root template in more depth in this unit. Reference: look at the render page method in your Magento implementation to see how the template name is obtained. In this updated flow diagram, you see that two methods have been added. They are called in by page render. The first method should be familiar, as we've seen it already when going through the View object-based rendering system. It is the same call as public build. The second method, a call to response append body, will add generated HTML to the response object. We will see what happens there on the next slide. As we saw on the previous slide, the render page method includes root template, which echoes multiple variables. The render method is where those variables are obtained. The most important one is, of course, layout content, which is a main part of the page's HTML. This variable is generated using a layout mechanism we will discuss later. The new Magento 2 page system has two steps, build and render. Magento 1 uses the interface load layout, generate layout, and in this updated flow diagram, you see that two methods have been added. They are called in by page render. The first method should be familiar, as we've seen it already when going through the View object-based rendering system. It is the same call as public build. The second method, a call to response append body, will add generated HTML to the response object. We will see what happens there on the next slide. As we saw on the previous slide, the render page method includes root template, which echoes multiple variables. The render method is where those variables are obtained. The most important one is, of course, layout content, which is a main part of the page's HTML. This variable is generated using a layout mechanism we will discuss later. The new Magento 2 page system has two steps, build and render. Magento 1 uses the interface load layout, generate layout, and then generate blocks. The new Magento 2 system implements the same steps in code that we had in Magento 1, with the exception of this layout, get update, load, inside of View, Layout, Builder, Build. We have three actions, load layout, generate layout, and load layout blocks. Remember, Magento 2 has the same code as Magento 1, except with layers on top. The concept of the page builder is that you build a page step by step. Reference: to see how the build system works in the code, do the following. Go to Magento, Framework, View, Page, Config.php in your Magento installation. Note that it does not extend to anything, it is just configuration, and does not parse any files. Public build just calls build. Next, look at the builder, which extends view layout builder.php and implements the builder interface. This code is very similar to that of Magento 1. We are looking at the Magento We are looking at the Magento Framework View Page Config class, and you can see it doesn't extend anything. This class is not a typical config class. It is not associated with any configuration files. This class only serves certain needs of the Magento 2 view system. Here we see the public build method. All it does is to call this build. At the same time, the build method of the config class calls the build method of a builder object. Let's take a look at where the builder object comes from. We can see the setBuilder method that will allow you to set a custom builder, but in this case, the builder object comes from the constructor. It is injected using the DI mechanism. Looking at the builder.php file, we can see what's inside the builder. It extends the layout builder class and is quite complex. It includes some familiar items like generate layout blocks, which we remember from Magento 1. Let's take a look at the framework view layout builder class, which is the parent of the class we've just seen. We see the load layout updates, generate layout XML, and generate layout blocks methods, the same steps we've seen before. This looks like an old Magento 1 system inside of a new Magento 2 system as an implementation of the build method. You can follow the load layout updates, generate layout XML, and generate layout blocks methods in your guide. In this module, we will discuss the primary view elements in Magento 2. In Unit 1 of this course, you were introduced to containers and blocks. In this module, we will go into more detail about both of these elements, as well as introduce UI component. There are three types of view elements in Magento 2: UI components, containers, and blocks. In Magento 1, we have only blocks and form elements under lib, variant, form. Conceptually, UI components are relatively standalone, reusable elements that can be presented on the page. Magento 2 uses UI components for grids, forms, minicart, and so on. As UI components are integrally related to JavaScript, we will cover this topic only on a high level. Simply attach any element to a container and it will render it automatically. With a container, you can define wrapping tags, CSS classes, and more. The purpose of developing containers in the beginning was to create events in templates. You don't have to rewrite a template, you just place the code. This ended up being the same as text list blocks in Magento 1. In Magento 2, the name container is new, but the concept behind it is familiar. Later we will see how containers are rendered. You cannot create instances of containers because they are an abstract concept, whereas you can create instances of blocks. you still have an analog of core text list blocks in Magento 2, and you can use them in the same way as in Magento 1. This slide shows how a container is rendered. As we have already discussed, Magento won't create an instance of a container, but instead will render all its children. We can see from this code that there are a couple of new possibilities that containers bring when compared to the core text list block. 1. An ability to define a wrapping tag, and 2. An ability to set attributes to the wrapping tag. Here we are again in Render Container. You see there is no instance of container. Container is abstract. So, we render a container and allow it to resolve, and it takes all the children and renders them. The children could be another container, element, or class. As we can see here, it takes the HTML tag, HTML ID. This slide shows an example of empty.xml. It defines a basic page body structure by defining a group of containers. This is analogous to root.phTML in Magento 1. This slide demonstrates Here we are again in Render Container. You see there is no instance of container. This slide shows an example of empty.xml. It defines a basic page body structure by defining a group of containers. This is analogous to root.phTML in Magento 1. Element, or class. This slide demonstrates a one-column.xml file. As you can see, it updates containers from empty.xml, generating a one-column page structure. In Magento 1, we have the one-column.phTML file. Magento 2 has an XML equivalent. In this section, this slide shows an example of empty.xml. It defines a basic page body structure by defining a group of containers. This is analogous to root.phTML in Magento 1. This slide demonstrates a one-column.xml file. As you can see, it updates containers from empty.xml, generating a one-column page structure. In Magento 1, we have the one-column.phTML file. Magento 2 has an XML equivalent. In this section, we will go into more detail on the role of blocks in layout. The layout of a page is determined by containers, which act as a framework and do not contain actual content. The content segments within a container are called blocks. Examples for content blocks might be a filter navigation, a page title, or a product add to cart form. Blocks can also be viewed as part of a page, an element of a page. Most blocks are templates, but some are not. Each web page within Magento is a hierarchy of containers comprised of blocks that, in turn, can contain any number of child content blocks or child containers, and provide handy extension points to other modules that place content on the page in the same area. Layout structure is discussed in detail in a later section. Every page consists of a hierarchical structure of blocks. The layout does not define the location of blocks on the page. It just defines their sequence. How the blocks actually look on the page depends on how the page is rendered and on the CSS. The slide diagram shows the relationship of blocks to the page structure. There are different types of UI customizations that you can make to a website. For example, you can change the look and feel, add an image to the page, or change the style of the fonts on the product listing page. In general, Changes to the look and feel of a site involve the layout, while adding something to a page most likely involves blocks. Changing the style of an element on a page can be accomplished using CSS code. In Magento 2, the structure of a page is more complex than in Magento 1, but conceptually they are the same. The structure is defined by layout XML files, and blocks, usually connected to templates, are generating content in that structure. Within each template, access to the blocks instance provides access to the data. So templates draw elements within a page, and blocks contain the data or contain a method that allows the template to access the data. It is the page render method that renders the root template, which includes other content blocks. As mentioned earlier, the role of blocks is in adding content to the structure defined by Layout XML. Layout XML is a hierarchical structure of blocks. Magento renders those blocks and generates HTML content to be included in layout content. See your user guide for a high-level overview. This is the code for a root template. Layout content is basically where all layouts are rendered. As you can see, the root template is only a few lines of code. It contains PHP echo commands which display certain variables. The question is, where do these variables come from? To answer this, we need to go back to the render method. The code highlighted in orange shows the layout output and how the generated layout content is being assigned to be included in root.phtml later. The data comes from page render, the parameters come from the layout, and the layout content variable comes from this getLayout getOutput. Now we can improve the flow diagram. Note that before including the root template, we have the step layout getOutput next to page render. So it will go to page render, then layout getOutput, before it comes back to the normal flow. When layout getOutput is executed, most elements on the page are rendered. This is important because blocks play a big role here. This slide illustrates what is happening with layout getOutput. Recall that in Magento 1, getOutput goes through every output block and performs a call to the method, specified in the output attribute, which is always toHTML. In Magento 2, the rendering system will take into account the view, base, page layout, empty.xml. Empty.xml, consists of a list of containers, and every container has some blocks attached to it by other layout updates. Note that each container has blocks assigned to it. Each block will usually, but not always, render a template. The template may or may not call another block, which would then call another template, and so on. A block is rendered in Magento 2 when it is called from the template. So, even if it is generated, a block will not be rendered until it is called from another template. There are a few exceptions, such as the core block.
This module discusses block architecture and lifecycle. In this module, we will study blocks in further depth, examining their architecture and lifecycle. We will start our analysis with block interface and abstract block. Block interface has only one method to be implemented. On this slide, you can see a list of important methods that the abstract block class contains, namely _prepareLayout, addChild, _toHTML, _before_toHTML, _after_toHTML, and toHTML. Later in this module, while analyzing the different phases of the block lifecycle, we will discuss these methods further. _prepareLayout, a specific method that is executed when a block is created. It is often redeclared in a specific block and contains certain initialization operations. children operations. As block structure is hierarchical, there is a need for methods to add, remove, find, and sort children. Underscore to HTML, underscore before to HTML, underscore after to HTML, and to HTML. These methods are executed right before rendering. They are also redeclared quite often in blocks. Note that to HTML needs to be implemented. Underscore to HTML is the place in the code where rendering actually happens, and underscore before to HTML is a trigger that allows certain actions to be performed right before rendering. The most important code lines in the example are highlighted. This diagram depicts the abstract block execution flow. It starts with underscore prepare layout and flows through a set of methods until it reaches underscore after to HTML. This is, in essence, what you have to know about block execution flow. Note that to HTML is final in Magento 1. In Magento 2, it is not final, and it is not recommended to override this method. What is recommended is to override underscore to HTML. That is where every block type can implement its specific rendering logic. Let's take a look at different block types. The most important block types are text, list text, messages, redirect, and template. What is block type? It is basically an implementation of an abstract block. We have seen previously that in the abstract block flow, the underscore to HTML method has to be implemented for every block type because it is not defined. The different classes extend the abstract block. Abstract block implements its own underscore to HTML method where the underscore to HTML method is called. Each specific block type implements underscore to HTML where the type-specific rendering logic is located. To understand what the text block type does, let's take a look at its underscore to HTML method. The most important code line, which demonstrates rendering, is highlighted in the example. In this diagram, items 1 to 5 represent child 1 to 5. In other words, the block's underscore to HTML method goes to every child and calls that child's to HTML method. This is a unique case where the method for list text automatically renders all the children. See the reference in your user guide. List text compiles and renders its children in one text variable. The fact that list text renders its children is an exception. Usually, blocks should be called from some other template to be rendered. Note that this is similar to containers. So we have several methods that accomplish the same task, but containers are stricter than list text. The block type messages is designed to render messages in different ways. For example, error will be rendered as a red message in a pink box. Note will be a green message in a beige box. An HTML redirect automatically directs you to another page. In Magento 2, a redirect block renders a JavaScript redirect. There is also the option to perform a PHP redirect, but it is not used in this case. When a template block is rendered, the template file is included in the context of a block, and its content is captured with the ob_start, ob_end_clean methods. We will go into more depth on this process later in the course. There are multiple ways to pass template files to a block. Set template method. Use when you have physical access to the block instance. Constructor argument. In the data array, it then goes to the _construct method. The diagram represents the flow used when changing a template layout. The flow for rendering a template goes from underscore to HTML to fetch view, after which there is a call to template engine render. Finally, it includes the file. In Magento 1, all templates are included in the body of a block. which makes the block a natural container for the template data. In Magento 2, it is possible to specify another object as the data container for a template. It is also important to recall from a previous slide that now templates are included, not in a block's body, but inside of a template engine, which forwards calls to public methods from template to block, so it still works as in Magento 1, but only for public methods. Creating a new block can be accomplished using layout, more specifically by calling layout create block. Note that this is the preferred way. If needed, the layout method will call the object manager. Also, you can directly use the object manager. Blocks can be customized as with any other class by using dependency injection and plugins. See your course Exercises Guide for instructions on how to complete this exercise and its solution. We will now switch to life cycle. In this topic, we will see how a block is created and then rendered. In Magento 1, there are two phases of the block life cycle: generating blocks and rendering blocks. Magento 2 also follows this two-phase schema of generating and rendering. Blocks are instantiated at the moment the layout is created. They are not executed at that time, just instantiated. Also during this phase, the structure is built. The children of blocks are set, and for each block the prepare layout method is called. However, nothing is rendered as that happens in the later rendering phase. You have seen this diagram before in this class. It shows how blocks are generated. It has 3 steps, as we have seen before with the build method. The results are load layout updates, generate layout XML, and load layout blocks. In Magento 1, there are similar methods. This slide displays details about layout generate elements. Generate pool is an instance of Magento, framework, view, layout, generate pool, and it is generators with the following elements: view page config generator head, view page config generator body, view layout generator block, view layout generator container, view layout generator UI component. See the reference example in your guide. The diagram demonstrates how the process method of the generator block class works. First, the generator block object goes through all the block declarations and creates an instance of every block by calling the generate block method. The right side of the diagram shows you how that works. You should understand, at least at a high level, how classes are being instantiated, as illustrated on this slide. There are 5 intermediate calls before the execution flow goes to the object manager, which creates all the objects in Magento. Next, the generator block object goes through all generated blocks again and performs a call to the set layout method, which calls prepare layout. Again, it is very important to understand that the prepare layout method is called at the moment of block instantiation. There are many, probably most, classes in Magento that have underscore prepare layout overridden. Usually there is some configuration initialization code located in this method. We will see more examples of this code later. Generator pool constructs an array of generators. Here we see the process method. We end up with the generate container method. Remember, the container is not an object, so it cannot be instantiated. Block.php implements the generator interface. We can see here generator interface with its 2 methods, process and getType. Here is the generator block object using the generateBlock method to create an instance of all blocks. The block instance then goes to blockfactory.php, and it goes to Object Manager, which creates the block object.
The diagram demonstrates how the process method of the generator block class works. First, the generator block object goes through all the block declarations and creates an instance of every block by calling the generateBlock method. The right side of the diagram shows you how that works. You should understand, at least at a high level, how classes are being instantiated, as illustrated on this slide. There are 5 intermediate calls before the execution flow goes to the Object Manager, which creates all the objects in Magento. Next, the generator block object goes through all generated blocks again and performs a call to the setLayout method, which calls prepareLayout. Again, it is very important to understand that the prepareLayout method is called at the moment of block instantiation. There are many, probably most, classes in Magento that have _prepareLayout overridden. Usually there is some configuration initialization code located in this method. We will see more examples of this code later. This slide shows how containers are generated. Since a container is not a physical class, there is very little to generate, which corresponds to what we're seeing in the code snippet. The process method of a generator container only manages attributes. This code shows how the UI component is generated. UI component is a class and often a block, which is why it has to be instantiated. The highlighted lines show what is happening in the UI component factory object, an instance of Magento, Framework, View, Element, UI component factory. At the moment of this class's creation, that functionality hasn't been totally finished. We now switch to the second phase of the block lifecycle, block rendering. By rendering, we mean the process of generating a block's HTML. Usually it comes from a template, but as we've seen before, other options are also possible. This diagram shows the complete rendering process. First, it starts with the getOutput call to the layout class. At this point, we already have all the layout XML for the page generated, and all the block classes are created. Next, Magento renders all the containers from empty.xml. Each container has blocks assigned to it by the other layout updates. By rendering containers, all the blocks are rendered by calling their toHTML method. The toHTML method of a template block includes a template file that will call back the block for data it might need. Also, the template may have PHP this getChild HTML calls, which will render a block's child, and each child will render its children in the same way, and so on. This is a recursive process. In summary, the process starts with layout getOutput so that all the containers from empty.xml will be rendered, which then causes all blocks assigned to containers to be rendered and starts a recursive process of rendering templates.phtml files.
This module discusses templates in more depth. In this module, we will discuss template location, template variables, template rendering, fallback, customization. Templates are snippets of PHTML code that contain PHP elements such as instructions, variables, and calls for class methods. Magento 2 uses PHTML files as templates, just as in Magento 1. In Magento 2, templates are located in the module, more exactly in the module subfolder View, Area, Templates. In Magento 1, they were located in App Design. As templates can belong to different modules, you should prepend the template with the module name as a best practice. This will help you to locate template files and avoid file conflicts. You type the name of the module, /, and then the name. For example, catalog, product, view, price.phtml becomes Magento_catalog, /, catalog, product, view, price.phtml. Templates are fragments of HTML code with PHP elements. We could have PHP variables, PHP instructions, and calls for the methods of some classes. Potentially, we can define other types of templates. Templates will render a piece of HTML with the data taken from the HTML block. The difference in Magento 2 versus Magento 1 is that this is not really a block, but a template engine. How does it work? The diagram schematic provides an overview. In a template, there is often a call that refers to the block and performs the call to the getSomething method. The getSomething function could be public, private, or protected in Magento 1, but in Magento 2, a template can only call a public function. We will see why it works this way in the next 2 slides. See the code example in your guide. The diagram in code presents an example of how a template is rendered. A template is rendered when block_to_HTML goes to fetch view, then to template engine render to include the file name. The code example shows the function render, which includes the file name inside the template engine. The template file will be included inside the template engine and references template engine PHP or Magento framework view template engine PHP. This will forward every call from the template engine to the block, as shown on the previous diagram. This code is an example of a template that contains a mix of PHP and HTML with calls to the block. See the code example in your guide. When creating a template, the file name might be incomplete. Fallback resolves the file path, defining the opening parameters of the complete file name, so the file can be found in the system when called or referenced. Example, product view details.phtml falls back to Magento_catalog view frontend templates product view details.phtml. Fallback is useful in debugging, as going back through the fallback steps lets you know exactly what file is being rendered. It also facilitates customizing templates. In Magento 1, the fallback process is concentrated in the design package. The mag_core_model_design_package getFileName method makes a series of nested calls, which makes it difficult to debug. In Magento 2, the process is simpler. Magento 1 instead uses template file, which then goes to block fetch view, the engine render, and includes the file name. Block getTemplate file is the critical method in this process. This example displays the code for the method getTemplateFile. In this code example, the most important code lines are those where the fallback process happens. These are highlighted in orange. The resolver object is an instance of Magento Framework View Element Template File Resolver class. This code presents the getTemplateFileName method. See the code example in your guide. As you can see, the real job of finding the right path for a template is done in the _ViewFileSystem object, which is an instance of the Magento Framework View FileSystem class. This diagram shows files involved in the fallback process. The rule created via the rule pool detects where the file is located.
Let's look at the file system. We'll go to Magento Framework View FileSystem.php. Let's see what that file system class does. The methods being called are getTemplateFileName and TemplateFileResolution. You can see it goes to certain resolution classes. In the code, it indicates what the class is. Here is the constructor. There are 4 different file resolutions. You can see all the fallback files. Let's view the template file resolution, the second one in the list. We go to Magento, Framework, View, Design, File Resolution, Fallback, Template.php. You can see template file extends file. And so from here, let's go to Framework, View, Design, File Resolution, Fallback, File.php. This file has a resolver method, and it has a getFile method, which loads the resolver. In the resolver, we have alternative.php and simple.php, possible completions. We can verify if getFile is simple. We can check the di.xml file, but this way it's just faster. So you can see here, it is simple. Again, we could check by global di.xml in Magento, app, etc, di.xml. Let's look up the resolver. You can see we have many resolvers. Let's go to the rule pool, Framework, View, Design, Fallback, rulepool.php. So we have rule pool, and in the resolve function, we have the resolve.php file with rule pool get rule. This is where the fallback happens, in the modular switch method. You can see here, it takes a look in 4 places. In the current theme, which is theme_path, theme_path in the module. Then you have module area and module base. This is extremely flexible if you want to customize it in the di.xml. You can set another rule pool, which will add something to that fallback.
The code example shows the creation of a template file rule. Magento will check for the file name in these folders. This code example shows the resolve file method from the Magento, Framework, View, Design, File Resolution, Fallback, Resolver, Simple class. This is where the path to the file is determined. In Magento 2, you can create and rewrite new themes as a core template in the module. There are 3 general steps in rewriting the core template. Create your module, create a new template in your module, set your template to the block that contains the core template to rewrite. Layout XML is a tool to build the pages of the Magento application in a modular and flexible manner. It allows front-end developers to describe the page layout and content placement without regard to how each rendered content part will look. In this module, we will discuss design patterns, page sections, containers, blocks, and layout files, merging files, directories, and schemas. There are 2 main phases in working with the Layout XML as depicted in this 2-step view. 1. Create the page content structure. 2. Render that structure. The whole idea of the Layout XML is to define the logical page structure. The first step is to create a logical page content structure, and the second step is to generate the HTML output. There are a few changes in Magento 2. The first change is that each update handle resides in its own file. In addition, it is now a little more expressive and explicit. Each Layout XML file is validated by the schema file, which should make XML syntax issues much easier to identify. This course focuses primarily on step 1. Note that a module can add content to existing pages without changing files in another module. It can also move or remove existing content added by other modules. Once all the Layout XML instructions from all the modules have been processed, the result is rendered and sent to the browser for display. In Magento 2, the page has been split into different parts. The head, the body, most of the content visible to visitors is defined within this section, HTML, and update. The first 3 Layout XML sections correspond with their HTML page tag equivalents. Each of Magento's Layout XML sections is used to manipulate the corresponding part of the HTML page. Update is not really a section. It is used to include more page processing instructions in separate files, helping to avoid code duplication. In Magento 1, the page structure is very generic. Layout XML can be used to describe any kind of content. It is not inherently bound to an HTML representation. You have a Layout XML file and the theme fallback. If you create the same Layout XML file earlier in the theme fallback, then it would not be inherently bound to an HTML representation. Usually, developers just copy and modify whatever is needed in a new version of the file. The big issue is that upgrades need to be made in the new version of the file, and this can represent a lot of work. In Magento 2, the Layout XML schema has been modified so that it is suited for HTML specifically. The default behavior with inheritance fallback means that it collects all the XML files and then merges them together. Note that it is still possible to overwrite files, but that it is now the non-default behavior. You have to use a special overwriting directory. It is not a recommended practice because that will introduce the same upgrade issues as with Magento 1. This slide should look familiar as you saw it in an earlier section. Recall that the layout of a page is determined by containers, which act as a framework and do not contain actual content, and that the content segments within a container are called blocks. Example for content blocks might be a filter navigation, a page title, or a product add to cart form. Each web page within Magento is a hierarchy of containers comprised of blocks that in turn can contain any number of child content blocks or child containers. These provide handy extension points to other modules that place content on the page in the same area. For this reason, the hierarchical page structure is sometimes also called a page tree, with the root referring to the parent containers and the child block and container elements as the branches. The leaves would refer to content blocks that don't have any further children. Blocks can also contain child containers to provide extension points to other modules that place content on the page in that area. By creating layout XML files as part of a module or theme, Magento will load and merge these files on the appropriate page. There are two places where you can find layout XML files: modules and themes. Modules. Layout XML files come from the module directories. Within each module are the view directory and the template files. Also within the directories are an area, which will be front-end or base or admin HTML. Also within the directories are an area, which will be front-end or base or admin HTML, and the layout files. Themes. In Magento 1, the base theme is base default. In Magento 2, the module directory is the new base theme. Now every layout file is clearly identified with the module. You can't have a layout that is not identified with the module. The theme directory structure is app, design, front-end, or app, design, admin HTML, then namespace, theme, etc. To allow separate modules to manipulate the same page, Magento uses XML merging, a very similar process to how configuration XML files are merged together. With Layout XML, in addition to the merging of files from each module under app, code, view, layout, layout files from within module directories can also be extended or overridden by themes. In the layout file, there are two possible root nodes, page and layout. Page. There are 4 different root nodes or page sections in a page. The first is HTML, then body, header, and update. Layout. The layout root node does not allow other nodes to be placed inside it. Why are there different root nodes? Page represents a full page in HTML. Layout represents a part of a page. If you want to render only a section of an HTML page, then you want layout. If you want to render a container or a block, then you also want layout. However, if you want to render a full page, then you want page. Page layout is a subset of page. We can only define attributes. The attributes will be set in the HTML tag in the root template. You can specify what you want here, and it will be rendered as an attribute. Let's say you want to add a JavaScript file or CSS file as a resource for the page in the Layout XML file. In Magento 1, there are different options available: reference name, actions, items, and so on. With Magento 2, we now have explicit tags for each of those things. Internally, they all do exactly the same thing, except for the attributes that we had in Magento 1. All the CSS script links are adding assets to a page. You may feel it is a lot more complicated now, but thanks to the auto-completion and schema tools, it turns out to be much easier.
The head section is a new element in Magento 2. In Magento 1, there is a special head block where we can have JavaScript and CSS files. In Magento 2, the approach has changed a little. Recall that the process of rendering in Magento 2 uses root.phtml, which includes layout content in the body tag, while the head section is rendered using head section. So, the head section corresponds to the HTML head tag and allows you to manage everything that is placed there. For example, we can add JavaScript using the head script element, as shown on the slide. The head section CSS element can either take a direct file name or module name. This slide shows the link element of the head section. As we can see on the slide, there are three attributes available: source, IE_condition, and defer. Their meaning is explained on the slide. This slide shows the remove element of the head section. In the example, it allows the removal of a JavaScript library from a page. This slide shows the title element of the head section. It allows you to manage the content of the title tag within the head block of the HTML page. This slide shows the meta element of the head section. It allows you to add the meta tag within the head block. This slide shows the attributes element of the head section. It allows you to define attributes of the head tag. An example of why this might be useful is shown on the slide. The next big section, and probably the most interesting one, is the body section. This is where you can add the actual content. There are attributes inside the body that are set by the attributes in the body tag. You can declare the containers and can move elements with blocks. The child-parent relationship is basically replaced by move. When you reference blocks and containers, you have to explicitly state what is being referred to, like reference block or reference container. If you reference a block, you have the same children available as in a regular block. Finally, there are remove and UI components within the body section. Note that the container acts as a page HTML wrapper instance because it can specify HTML tags. Name is an attribute of the block directive, which works in the same way as in Magento 1. The attribute element allows you to define the attributes of a body's tag. The container element defines a Magento 2 container within the body section of a page. Recall that a container allows modules to add content to that section of the page. In Magento 1, the reference layout directive is probably the most important tool for any layout updates. In Magento 2, reference directives like reference block and reference container function in the same way as in Magento 1 and allow you, for example, to add a child to a block defined somewhere else. The reference container is the container analog of reference block. It functions the same way as reference block, but for containers. The remove element, as implied by its name, allows you to remove any layout directive from the resulting XML on a page. It uses name to reference the node to remove. UI components are predefined generic block instances that can be configured using Layout XML as needed. The most common use case is admin HTML grids. Each block can take arguments which are then passed to the constructor part of the data that is injected into the block through the Object Manager. Each argument has a name and a type. String is the simplest type. The name is important because it has to be unique in the argument list. If you have two different Layout XML files and both reference the same block, then the second one with the same name in the sequence will replace the first one. This is a very easy way to change blocks into arguments. The argument's argument node is used to populate the data array of the containing block. Note that in Magento 1, to set data, you use action with magic setters or setData method. The action node is used to call methods on block instances. Argument names have to be unique within the containing action. Note that while this element is used in the core, it has been deprecated, so it is best not to use it. One of the most interesting argument types is the array. You can register as many items as you want within it. This can be both for arguments and for action arguments. The XSI type array can be used to construct argument arrays. The arrays may be nested to any depth. Each item in an array is declared with an item element, which in turn can be any of the argument types. When merging, if two items within the same parent, the argument node, share the same name, the second one will overwrite the first. This module discusses the loading and rendering of Layout XML. In this module, we will discuss directories, layout areas, theme inheritance, overriding layout, handles, Reference. Locate the following file in your Magento installation: app, code, Magento, checkout, view, frontend, layout, checkout_cart_index.xml. These files are collected using Magento, framework, view, layout, file, collector, aggregated, which in turn delegates to the following collectors: Magento, framework, view, file, collector, base, Magento Framework View File Collector Theme Modular, Magento Framework View File Collector Override Base, Magento Framework View File Collector Override Theme Modular. Along with layout files loaded within the module directories, additional layout files are loaded from theme directories under App Design. Reference. Locate the following XML file in your Magento installation: app, design, frontend, Magento, blank, Magento_catalog, layout, catalog_product_view.xml. The system looks for these types of files to load: the view areas within the modules, base, admin HTML, frontend; the view areas within the theme directories, admin HTML, frontend. The files from within the admin HTML and frontend areas are combined with a small number of layout XML files in the base area. The layout file is always one of the following combinations: base plus admin HTML, base plus frontend. Not every page tag needs to specify the layout attribute. It is used only when creating a new page or changing the layout for an existing page. In Magento 2, there are not only layouts but also page layouts. The layout XML files in the page_layout directories follow the same syntax rules as the layout XML files located in the usual layout directories. The XML files from the page_layout directories are combined with the list of files from the layout directories using Magento, framework, view, model, layout, merge, _load file layout updates XML, and are treated just like any other layout XML file thereafter. Out of the box, you get 3 page layout directories located in Magento theme. Magento page layout files contain the base for the type of page layouts you want. For example, 1 column, 2 column left, 2 column right,
and so on. If you create the layout result object, it only includes the regular layout because it requires the root templates to be rendered by the page object. When the XML files are loaded, Magento applies an inheritance theme at the same time. You can apply a theme and it will look for the parent until a theme without a parent is reached. How do you debug theme inheritance? Look for an entry point so you can locate the method getInheritedThemes, and with that you can figure out the inheritance. Themes in Magento can inherit other themes. This is configured in a theme.xml file or composer.json file within the theme. The list of theme layout XML files is built by recursively looking within each theme in the inheritance list for a matching XML file. Usually, the last parent theme is Magento blank. Developers can create completely independent theme hierarchies. Note: Magento 1 uses primarily a theme fallback concept, while in Magento 2 it has been completely replaced by a theme inheritance concept. These concepts work similarly, but the Magento 2 version provides more flexibility with the option to put layout XML files into module directories. Starting with Magento 1.14 EE 1.9 CE, inheritance is also supported in addition to the theme fallback, but not the placement of layout XML files in module directories. Overriding layout XML is not a good practice, but it is sometimes necessary to use. Basically, it replaces a file in the fallback. Note that Magento 2 differs from Magento 1 in that you have to specify which file you want to override. Base override files replace files from the base theme, and theme override files are from a specific parent theme. See the code examples in your user guide. This is an example of the file system structure for a theme containing two layout XML files. The Magento _checkout layout default.xml file will be merged with all other default.xml files from the parent themes and all modules. The Magento _catalog layout override theme Magento blank catalog _product _view.xml file will replace the file with the same name from within the Magento blank theme during the merging process. The file theme.xml is not a layout XML file. It is a theme configuration file containing, for example, the theme title and preview image name. Layout handles or update handles are how the Magento view knows which layout XML instructions to process for a given request. Almost every page in Magento is associated with the default handle. It is used to set up the main containers and content elements that are available on every page. If more than one layout handle is associated with the request, the default handle is always processed first. The page-specific action handle is used to add content to the generic page structure defined by the default handle. The action handle is always processed after the default. The contents of update handles are processed in the order in which the update handles are added. To add custom update handles, the method addHandle can be called on the result page object. Magento Framework View Result Page, or Magento Framework View Result Layout, before the response is rendered. Alternatively, custom handles can be added using the Layout XML Update directive. Congratulations! You have completed Unit 3 of the Fundamentals of Magento 2 development course.